Hello students, I am Sister Mary here. Welcome to 10th Maths NCERT Chapter 1 Real Numbers. Today we will study the concept, the fundamental theorem of arithmetic. As you see, the topic of today, don't think that is going to be complicated. It's very easy, which you have already done in your smaller classes. Only now we are going to study the proper definition of it. The fundamental theorem of arithmetic. Let's see. Every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. You know what is the meaning of composite number? Composite number can be factorized, and those factorization will be unique for that number apart from the order in which the prime factors occur. Meaning to say, example I am given here for you to understand in a better way. For example, 30 we have taken. 30 is a composite number. Now, if you factorize the composite number, this 30, we will get the prime factors of 5, 2, 3, or we'll get 2 or 3 and 5, or 2, 5, 3, depends upon how you are factorizing. So when you are factorizing, these are the factors you will be getting, but what we are trying to tell you is the factor is unique. See, factorization is unique. These factors cannot be changed. What are the factors? 5, 2 and 3. Here also you see 5 is there, 2 is there, 3 is there. Here also you see 5 is there, 2 is there and 3. So these 5, 2, 3 are the factors of this 30. So that cannot be changed, but their order can change. See, here we begin from 5, then becomes 2, then 3. Here we started with a 2 and then 3 and 5. Here if you are factorizing from 2, then you will do it 5 and then 3. The order might change, but the factors remains the same. You can't have other prime factors here for this 30 than 5, 2 and 3, or you can say 2, 3 and 5. So order can change, but the factor remains the same, or the factor is a unique. That's what explained here. Every composite number, for example 30, we have factorized as a product of primes. So these are the primes, but this prime is the unique apart from the order in which the prime factors occur. So order can be changed. So you can change the order of the prime factors, but can't change the prime factors. So you can't have other number instead of 2, 3 and 5, but the order can be changed. So that's it. Now next, generally this given composite number, for example any composite number, we factorize it as x equal to P1 into P2 into P3 and goes on and on Pn. It goes on. What is the meaning of this? Meaning is, we normally do the factorization. So any composite number, if we are doing the factorization, it is in ascending order. So we will see the example. A prime factorization is in ascending order. For example, we factorize 210. We factorize 210 and 385. So when we do the factorization, we have to begin from smallest number, then the smaller, and then will become the bigger ones. So you see here 5, then we do with 7, then 11. You see the order here, 2, 3, 5, 7, 5, 7 and 11. So it is in ascending order. That we have to keep in mind. Many of us, we just do the factorization, but then we don't keep up this ascending order. So it has to be in the ascending order. Now, why do we need to learn this prime factorization? You know already the prime factorization. So with the help of prime factorization, we can calculate HCF and LCM of 2 or more positive integers. Already I have taught you what is HCF in Euclid's division algorithm. HCF means highest common factor. But what is the difference? In Euclid's division algorithm. Using Euclid's division lemma, we were calculating HCF of given two positive integers. But using prime factorization, we can calculate two or more positive integers. That is the advantage of it. In using Euclid's division lemma, we can calculate HCF of only two positive given integers. But with the prime factorization, we can calculate two or more positive integers. So here HCF and LCM of two or more positive integers we can calculate using prime factorization. You know already the prime factorization. You know also HCF. Now what is the meaning of LCM? I'll explain to you. LCM meaning is least common multiple. For example, suppose we have two numbers 3 and 5. So let's take 3 and 5. So in number line, the positive side we will take in number line. You have the numbers here. Now if you are taking the multiples of 3, so where we will have here 3, 6, 9, 12, 15 and it goes on. If you are taking a multiple of 5, then you begin here 5, 5, then 10, then 15, then goes on. But if you see both this number, where do they meet? They meet here. The multiples of 3 is 15 here, multiples of 5 also 15 is here. So at 15, at this juncture, at 15, both these numbers meet, and therefore we say the least common factor for 3 and 5 is 15. Only this actually no need to get confused, just to understand the meaning of least common multiple, meaning to understand. But then when we start calculating HCF and LCM using prime factorization, this concept will be very clear to you, which we will see in the next video, how to calculate HCF and LCM using prime factorization. That's it. Thank you. God bless you.